Hello everyone. Today we are going to discuss related to amplitude modulation. So in that video, I am going to discuss how to draw amplitude modulated signal, frequency spectrum of amplitude modulated signal, bandwidth of amplitude modulated signal, and few examples. So first, let's see how to draw amplitude modulated signal. So all of you are aware of equation of or some mathematical representation of amplitude modulated signal. EAMT is equal to VC plus EMT into sine omega CT. This is the mathematical representation. Now how this can be represented in form of waveform or say graphical representation of amplitude modulated signal. So as you can see here, there are different parameters. VC is what the peak amplitude of carrier. EMT is the modulating signal or baseband signal or information signal, low frequency signal, and sine omega CT, it is a carrier signal, high frequency signal. So see here it is modulating signal, low frequency signal. So you can see here it is uh, focused at zero level, means in this signal it is centered at 0 and its peak value is 1, right? So it is EMT is equal to, we can write Vm sine omega t, where Vm is equal to 1 volt. This is the carrier signal, high frequency signal. As you can see, it has high frequency and its peak value is 3. Here in modulating signal, low frequency signal, peak value is 1. Here in carrier signal, peak value is 3. Remember this. Now as per this equation of modulated signal, here the peak amplitude of carrier is varying, means peak amplitude of modulated signal is varying according to this VC plus EMT. So first let us add VC, means peak amplitude of carrier, and EMT is time varying signal. So see, if we add some level VC to modulating signal, then it's looks like this. It looks like this, right? Means this signal which is originated at 0 level, that is now clamped at value VC. VC is what? Peak amplitude of carrier. Peak amplitude of carrier is 3. So now this signal is now centered at level 3, as we can see in a waveform. So this VC plus EMT is nothing but what? This is clamped, this signal, modulating signal is clamped at level VC, nothing else, right? So the peak amplitude of this modulated signal is now varying according to this, right? So that you can see in this waveform, and this is nothing but what? Modulated signal, means at a different instant of time. From this you can see, for different instant of time, the peak amplitude of this sine wave is different, right? Means if you consider here it is t is equal to 0, so at t is equal to 0 the peak amplitude of modulated signal would be 4. As time passes, the amplitude decreases and it becomes 2 at certain instant of time, then again it increases. So that you can see in this modulated signal, right? So similarly here, negative side, because when we draw sine wave, so it has peak value 1 volt, so we are indicating that peak at positive side as well as at negative side. So similarly for modulated signal, there is a positive envelope and there is a negative envelope, right? So this way you can draw the modulated amplitude modulated signal. Instead of sine wave modulating signal, if square wave, then here you have to consider square wave, and accordingly you will have amplitude modulated signal. So I hope uh, you will be able to draw amplitude modulated signal for any kind of modulating signal, right? You have to just focus on peak amplitude of VC and EMT, means modulating signal. So you can easily draw the amplitude modulated signal. Now next, the frequency spectrum of amplitude modulated signal. So you know the mathematical representation as I have mentioned here. So in this one, EMT is equal to, actually we are considering sine wave, so EMT is equal to Vm sine omega mt, right? So where omega m is the frequency of modulating signal or baseband signal or information signal, and omega c is the carrier frequency. So omega c is larger than omega m. Omega c is larger than omega m. So that is equal to, now when you multiply, so now when you multiply this sine omega ct with this bracket term, you will get this vc sine omega ct plus vm sine omega ct into sine omega mt, right? So now with this term, when you multiply and divide by 2, so this is the expression where you can see 2 sine omega ct into sine omega mt, means it is a trigonometric formula 2ss. 2ss is equal to nothing but what, c minus c, means cos omega ct minus omega mt minus cos omega mt, cos omega c plus omega m into t, right? So this vm by 2 as it is. Right? So here 2ss is being converted into c minus c using trigonometric formula. Now next, for sake of simplicity, again repeated here. So now with this equation, for second term, multiply and divide by vc by 2. Sorry, vc, multiply by vc and divide by vc, right? So vm by 2 as it is. So vm upon vc, it is known as m, modulation index. So now in this expression, substitute vm upon vc is equal to m. So here final expression is vm sin omega ct plus m vc by 2, because this vm by vc is now replaced by m. So it is m and this vc by 2 as it is. So m vc by 2 into cos omega ct minus omega mt minus cos omega c plus omega m t. Now when you multiply this mvc with this bracket term, so you will have mvc by 2 here, then this term minus mvc by 2, again this second term. Now you know minus cos omega t can be replaced as plus cos omega minus pi, omega t minus pi, right? So here it is shown here mvc by 2, means first two terms are as it is. This third term, that is here negative, that is being converted into positive with this formula, means cos omega c plus omega m t minus pi, right? Means here this minus sign is converted into positive by showing the 180-degree phase shift. So here there are three frequency components, as you can see: omega ct, omega c minus omega m, omega c plus omega m, and corresponding amplitudes vc, mvc by 2, and again mvc by 2. So from this equation we can plot the frequency spectrum, the magnitude spectrum and phase spectrum. So here it is magnitude spectrum. So at different frequencies, omega c minus omega m, and omega c plus omega m. What are the amplitudes? So amplitudes are mentioned here. For omega c it is vc, and for remaining two frequencies, omega c minus omega m and omega c plus omega m, there are mvc by 2, mvc by 2. Here frequency is in terms of omega, means in radian per second. So similarly you can plot phase spectrum at a different frequency. So at omega ct, means at omega c frequency, the amplitude is minus pi by 2. Omega c minus omega m, the phase is 0, and omega c plus omega m, phase is minus pi. So this is the phase spectrum. It is simple, and this we have already discussed in second sessional. Now here, earlier we have seen in previous ppt, previous slide, we have seen frequency is in terms of omega, means radian per second. Here now it is being converted into hertz. So omega is replaced by 2 pi f. Omega is replaced by 2 pi f. So here in magnitude spectrum, instead of radian per second on x-axis, here it is now hertz. So here corresponding frequencies fc, fc plus fm, fc minus fm, and their corresponding magnitudes. So here it is magnitude spectrum in terms of hertz, right? fc, fc plus fm, fc minus fm. Now see bandwidth. What is the bandwidth of amplitude modulated signal? So here for sake of simplicity I have repeated the diagram, means magnitude spectrum. So as you can see, bandwidth is nothing but what the bandwidth is given by f max minus f min. F max is the maximum frequency, f min is the minimum frequency in our spectrum. So here in our spectrum of modulated signal, amplitude modulated signal, the maximum frequency is fc plus fm and the minimum frequency is fc minus fm. So when you substitute f max and f min by fc plus fm and fc minus fm, you will get bandwidth is equal to twice fm. So where fm is what, it is the frequency of information or information signal or a baseband signal or message signal. So this bandwidth of amplitude modulated signal is given by twice fm. Remember this, it is important formula, where fm is the frequency of modulating signal or baseband signal. Now if we have again equation of modulated signal, amplitude modulated signal, where now let us consider EMT is equal to V1 sine omega 1t plus V2 sine omega 2t, where V1 is greater than V2 and omega 1 is less than omega 2. So here I have mentioned the condition omega c, means carrier frequency of carrier is greater than omega 2, again it is greater than omega 1, means here lowest frequency is omega 1, then omega 2 is greater than omega 1, omega c is greater than this 2. So now substitute this EMT in this equation, so you will get EAMT. This one again simple mathematics. So later on, again according to this previous procedure, this can be converted into cosine terms. As you can see here, this 2ss can be converted into c minus c using trigonometric formula. So here we have this term, then multiply and divide by Vc in this equation for last two terms. So where you can see V1 by Vc and V2 by Vc. So let us assume V1 by Vc is equal to M1 and V2 by Vc is equal to M2. So this ratio V1 upon Vc and V2 upon Vc are known as modulation index. So replace this V1 upon Vc by M1, V2 upon Vc by M2. So we have this equation, right, and corresponding magnitude spectrum. Corresponding magnitude spectrum. See, there are how many frequencies in this amplitude modulated signal? One is omega c, second is omega c minus omega 1, omega c plus omega 1, omega c minus omega 2, omega c plus omega 2. Means there are 5 frequency components, right? So these 5 frequency components I have mentioned here. Here frequency is considered in terms of radian per second and corresponding amplitudes are mentioned. So this is the magnitude spectrum. So see here I have mentioned M2 less than M1, means M1 greater than M2. So what is M1? M1 is V1 upon Vc. So here we have assumed V1 is greater than Vc. V1 is greater than Vc. That's why M1 is greater than M2. So here in terms of hertz, if frequency we consider in terms of hertz, so here it is fc plus f2, fc minus f2, right? F max is fc plus f2 and f min is fc minus f2. So bandwidth, again bandwidth is equal to f max minus f min. So f max is equal to fc plus f2 and f min is equal to fc minus f2. So bandwidth is equal to twice f2, where f2 is the highest frequency present in information signal. highest frequency present in information signal, right? So bandwidth is equal to 2 times f2. So do you get any idea from this equation? Bandwidth is equal to 2 times f2, where f2 is highest frequency present in information signal. Yes. uh, Bandwidth of amplitude modulated signal is given by 2 times f max, 2 times f max of signal. F max of f max signal means the maximum frequency of modulating signal or information signal or baseband signal, right? F max signal is nothing but what? Maximum frequency present in information or message signal or baseband signal, means EMT or VMT, right? So this is the important relation, means what is the bandwidth, that you can easily find out, right? So let's see now one example where EAMT is equal to this 4 plus 2 sine 2 pi 1500 t into sine 2 pi 10 to the power 4 t, right? So for this one we have to find out frequency spectrum and bandwidth. So can you find it out? It's very easy. So from this given amplitude modulated signal, means bifurcate different parameters like VC, VM, frequencies, means FM, FM, FC, and all. So let's see. Fm is equal to frequency of modulating signal, so it is given 1500 hertz. Fc is 10 to the power 4, means 10,000 hertz. Vm is peak value of modulating signal. Vc is the peak amplitude of carrier signal. So we know m is equal to Vm upon Vc, so m is equal to 0.5, right? And if you plot the magnitude spectrum, Fc plus Fm here maximum frequency, Fc minus Fm minimum frequency, so the difference is nothing but 3000 hertz. And you know the equation, bandwidth is equal to 2 times f max of signal. So here for our signal, modulating signal, the maximum frequency is 1500 hertz. So 2 times f max or fm will give you bandwidth of this modulated signal, so it is here 3000 hertz. So second example, so in this one, an information signal is AM modulated which contains 2 kilohertz, 5 kilohertz and 7 kilohertz frequencies. Find the bandwidth of AM signal. So okay, in this given modulated signal there are 3 different frequency components, 2K, 5K and 7 kilohertz. So here maximum frequency in modulated signal is 7 kilohertz, right? So bandwidth of AM signal would be 2 times of f max. So maximum frequency 7, so 7 into 2, 14 kilohertz, right? So here in summary slide you can find out the bandwidth of amplitude modulated signal by 2 times f max signal. Now this is additional information for you. Here I have mentioned this is the frequency spectrum of modulating signal, means if you have modulating signal and if you plot its frequency spectrum, amplitude spectrum or magnitude spectrum, so that modulating signal is available at frequency fm. Now in amplitude modulated signal, when you plot frequency spectrum so there are 3 different frequency components. One is Fc, Fc plus Fm, Fc minus Fm. That means this modulating signal is shifted at Fc plus Fm and Fc minus Fm. Means this right hand side part is known as upper sideband and left hand side part is known as lower sideband. Means this information signal is contained at 2 different frequencies, Fc plus Fm or Fc minus Fm. So in communication block diagram, using appropriate filter we have to choose either LSB lower sideband or USB upper sideband, and then that we need to transmit using antenna. So thank you. So if you have any doubt you can ask me on my personal contact number or you can email me. Thanks.